Hi everyone, and welcome to our live demo session. And today the focus of our session is going to be on how we can manage changes utilizing some features within EOS Studio. So I'll go through what we'll cover in just a moment, but first of all, a couple of quick introductions. My name is John Harrison and I work for IDERA. I'm actually based in Europe in the UK office, but I've worked with EOS Studio for some time now. I'm part of our technical pre-sales team. I believe my colleague Tim has also joined us, so he'll be sat in the background and we'll hopefully be able to answer any questions that you ask between us. So really briefly, just in terms of how do we categorize or how do we describe EOS Studio in just a couple of sentences? Well, primarily it is an enterprise grade modeling tool which allows data architects and other data modelers to document and design their data assets. It supports a wide range of different database platforms. I'll maybe talk a bit more about that as we go through the demonstration. And it also has features in there that allow the ability to share the data models, to have multiple people working on the data models at the same time, and also do versioning and version control of those. And we'll probably show very briefly the fact that it can also actually integrate with business glossaries and business terms as well. So you can see changes that are being made at that level also. Okay, just move on. Just a really quick look at the overall structure of EOS Studio. It's made up of three core pieces. On the left-hand side is EOS Studio Data Architect, and we'll spend a bit of time showing this in a live demo in just a moment. This is a Windows application, and this is where we create and maintain the actual data models themselves. So I won't go through that big long list of capabilities today, but this is where we could do things like our logical modeling, our physical modeling, reverse engineering, and also forward engineering to generate DDL code as well. A key piece that enables us to manage changes within EOS Studio is what we call a team server repository. So this does allow us to actually share the data models across a team of users. It will take control of versioning those data models. I can check out parts of the model when I want to make changes. I can then commit those changes by checking it back in, and it will maintain a history of who has made those changes with a date and timestamp as well. We can also add some additional information, as we'll see in the demonstration. Then the final piece on the right-hand side is what we call Team Server Core. And this is really an add-on to the Team Server repository, which adds web browser connectivity to it. So if you do want to share your data models with other people with different roles in your organization, you can enable the Team Server Core license, and they will be able to browse, to search and extract information from the data models using just a web browser interface. It's read-only; they can't make changes, but they can look at the information, they can search for it, and extract information from there as well. And it also does have the ability to store things like business glossaries and business terms, and connect to other kind of full-grade data governance solutions such as Calibra as well, and synchronize terms and glossaries between the tools. Again, if we've got time at the end, we might just show a little bit of that to give you an idea as to how that looks. So I'll just keep moving through. I've only got a couple more slides, and then we'll get into the demonstration itself. So just in terms of what EOS Studio can provide and how it can help you understand the data assets, and how it can help you document those and bring those together as more of a meaningful source of information. On the right-hand side, what we're representing here really is the fact that we can have a catalog of our data assets. So this could be an actual database. So it could be a SQL server, it could be an Oracle, it could be one of the NoSQL databases like MongoDB, or it could just be a set of documents or flat files on the disk as well. And the key thing there really is that that's very technical information. It's documenting what an asset is, and the structure of it in terms of the name of a table, the name of columns within the database, and so on. So what we're then able to do is take that data asset definition and transform that into something that's a little bit more meaningful, and that's typically a logical data model. So on the bottom left of the slide there, this is where we start to perhaps see more meaningful names coming through. We start adding additional context into the data model to explain why things are defined in particular ways, to add additional information in there as well to describe how they're used perhaps. So that's all possible within the logical data model. And then at the top left-hand side there, what we're also able to do is to connect that logical data model back through to actual business term definitions. So we can control how that information maps back into the business, into their own language as to how they define what a vendor is, how do they define what a company is. And again, we'll show you a little bit of that as we go through. So this is the basic agenda for today. As I say, the theme is really around how EOS Studio can help us manage changes and how we can do that effectively within the data modeling tool. So I'm going to start off just by going through a bit of a walkthrough on the actual repository itself. That's not too interesting to see because its core purpose really is just to maintain things in an integral way so that they can be shared, but I'll explain a few of the features and how it does that. Once we've gone through the repository, I'll then show how you can use the actual EOS Studio Data Architect tool to make changes and how we can manage those used in conjunction with the repository. We've got a really powerful tool called Compare and Merge, which also allows us to see differences between models and then control exactly what changes we want to apply to different data models as well. And then final few pieces, we'll go through how we can then take the data models and actually use those to produce change scripts or alter scripts that can be applied against the database to actually make changes to the schema. And then a few things that are related, I'll talk a little bit about enterprise data dictionaries, where we can define a definition in a single place of things like an attribute or a column, and then reuse those across different data models and across different data assets. So again, that helps us manage the change in terms of we're defining things once, but potentially utilizing them in more than one data model and more than one definitions of schemas. Universal mappings, again, we'll talk a little bit about that. This helps us with things like impact analysis, where we can link items that or might be defined differently in different data models and subsequently in different database implementations, but they are related to each other. So we want to have the ability to be able to easily identify that if we're making a change in one of these systems, potentially it might have an impact in making a change to other systems. And then, as I said, we'll finish off just by looking at how we can share some of this information with the overall business and how they can use EOS Studio to help them collaborate across things like business terms, business glossaries, and the data models themselves. Okay. I've got a few kind of just useful links that I popped in here. The slide deck itself should actually be available as a PDF file under handouts in the GoToWebinar client. So you're able to download this afterwards, and I'll put this slide back up again at the end. But what you will see is that we have a whole set of online documentation at our DocWiki page. That includes step-by-step tutorials for many of the things that we'll see today. And we do also have things like a YouTube channel and resource center on the main IDERA webpage, where you can also watch lots and lots of pre-recorded videos, on specific topics. Typically, they're kind of 10 to 15 minutes long and focus on how you do specific things within your studio. So there's lots of online free resources that you can get access to really easily and help you get going and working with your studio. If you do think of a question afterwards, or you want to follow up and maybe talk in a bit more detail about specific capabilities, if you go to the idera.com/contact sales page, you'll be able to submit a question which will come through to us, and we'll come back to you and see how we can help to resolve any questions or other things that you want to pursue. Okay, so I'm just going to drop out of PowerPoint, and I'm going to go across to my demo environment. And I'm also going to make this full screen as well, so just bear with me a second. And we'll review full screen. Okay, so this is your Studio Data Architect. So this is where we will actually create the data models and work with them. Within here, we can connect into the back end that is the team server repository. So if I click on the repository tab here, you can see that I've got the obvious things like log in, log out. I can get diagrams, I can add diagrams, I can check in, check out. We also support things like branching and merging within the repository. So if I'm working on a main kind of trunk of changes to the data model where I need to branch out to create a specific change that needs to be done immediately, we can do that in a separate branch and then merge that back into the main trunk afterwards. We can also create something called a named release, and these can be really useful. So a named release is a snapshot of the data model at the particular point in time. So I could be working on my data model, updating it. I've made some changes. Before I check those changes in, or after a number of people have made changes and checked them in, I could take a snapshot as a named release, and this is now my data model version 1.5 production system. I then continue working. We then take a snapshot. This is now my production system version 1.6, 1.7. And what that means is by taking the snapshots, I can always go back to a previous version of the data model, and I can also do a comparison between the current data model and previous versions. So what's different between 1.5 and 1.6? What's different between 1.5 and 1.7, and so on. So named releases are really powerful. And you can structure the repository as well. Again, as I say, it's not that exciting to look at, but we'll just bring a few things up. So we can have a basic folder structure. So underneath my data modeling projects, I've got something that are called corporate models. We have a description, and within there, I've got some specific data models in there. I could also have another folder called data catalog. I can also have folders within folders. So we could have subfolders representing our production models, subfolders representing our work in progress models, and so on. So the project center just allows us to manage that. And of course, there is a security model that's associated with the repository. So we can control who gets access to the data models, who can make changes to specific data models, and also who can manage things at the admin level in terms of creating new project structures, creating new folders, creating new data models, and so on. Okay. So this is a data model that's actually being managed by the repository at the moment, and you'll see on the screen it's got a number of these little kind of what look like lock symbols. So if it's a closed blue lock, that basically means the model is checked in. So I can't necessarily make changes to it at this point in time. And you'll also see, I won't talk about this in great detail today, but within RStudio we have a concept of something called submodels. So I can break my data model down into kind of different layers of the diagram, showing different objects on there. The objects themselves only exist once, so something like employee only gets defined once, but it could appear on any number of different submodels. And I can check things out at things like the submodel level. I can check things out even at like an entity or a table level as well. But generally speaking, if I'm going to be working on employee, it's probably going to make sense for me to also check out the other things that are directly related to it, or where there's a primary key relationship, as otherwise, those changes could be impacting those things, and that's not going to, RStudio will basically enforce that and tell us that we have to check those things out if we're going to make changes to it. So I can right click here, and you can access from the menu as well, but I'll just right click and I can see the version history. So as I make changes, and I'm very bad, I'm logged in as the admin user because it's just my demo environment here. And I can see that different versions, I've added an object, I've done check-ins, date and timestamps. And very usefully, we can also add in comments to this as well. So you can explain the reasons why you're doing the check-in, what changes you've made. And again, they'll all be captured in the repository. If I did want to make a change, and what happens when I check out? Well, we could just check out this submodel. So we'll go ahead and do that. And I could say, why am I checking it out? I can create more specific things like change records if I want to. So if I want to actually document more formally and store a change record in the repository, I can do that. Or in my case, I could just say that I'm checking out, updating training submodel or something of that nature. I'll just mention these things briefly here as well. There are some options within RStudio. We can do what's called checkout exclusively. And what that means is if I check out that submodel, no one else will be able to check it out at the same time. So I'll get an exclusive lock on it. The default way in which most of our customers work, even our larger customers, is they don't tick that box, and instead they do what's called a concurrent checkout. So multiple people could actually check out that same part of the model at the same time. They can make changes, and when they do their check-in, RStudio will basically do any kind of synchronization and manage anything that looks like it's going to overwrite changes that other people have made as well. So it'll do that kind of verification and manage those changes to make sure you're not losing changes that people have made. And that seems to work quite nicely even for large data models. We've got some of our customers in different industries with 25, 30 plus concurrent users working on data models. And it's very rare that you'd be you'd have multiple people updating the exact same object at the exact same time, and if they are, they probably need to talk to each other to figure out what's going on there. But if I do the checkout, so I'm talking away there, let's get on and do some things. If I do the checkout, it's basically just going to contact the repository, and you'll now see that all these icons have now changed to a green open padlock. So that means I have this checked out. So I could then go in and start making changes to it, or I could open up my employee, and that's then going to show me the content and the detail behind that, including all the different attributes and so on that are defined. Sorry, my machine's on a real go slow today for some reason. Okay, got there in the end. So there's the detail behind it. There's my attributes. I could add attributes. I could change them. I can update them. I can have things like a description of what this thing is. We can add additional notes. It'll show us the keys that are associated with it, the relationships, how it relates to other parts of the data model, and so on. So we capture a whole set of information behind the objects in the data model, and some of that does not necessarily have to be part of the database schema. It can just be adding more contextual information, and we'll see some of that on this diagram here. For example, we've got kind of a little, what we call a title bar, which is just summarizing what the model is, what this submodel is called, who created it, what's the company, what's the version. We can add notes or annotations onto the data model. We can add shapes and colorizations to kind of make it a little bit easier to read and to follow, and so on. And again, all that information will get captured as part of the data model and can be stored inside the repository. And within here as well, there is also this thing called a change management center. Actually, I'm not sure how much I've got in here because this is a relatively new repository, but I've got a few things. So we can define tasks and change records. So within here, as I say, if perhaps you're working on a more agile approach, which some of our customers do, they maybe have a set of tasks or changes that they want to make over a period of 6 weeks. You can actually define those as specific change records. And then when you do your checkouts, you can associate that checkout with a specific change record. And then when you check back in again, update that with the comments. So this gives you a little bit more kind of ability to kind of specify, where it's being used a bit more formally, description in there, and also reuse it across different people checking in and checking out as well. Final thing I will mention, I won't show this today, but if you do use an external task management system, in particular Jira, we do actually have an integration into Jira, which allows you to read the tasks directly from Jira and bring those into EOS Studio, and then you can then associate those tasks from Jira into your check-ins and checkouts within EOS Studio. Again, it's just really an extra form of documentation and capturing that change management as to why you're making those changes, who's doing it, and so on. We don't push changes back into Jira because we view that Jira would be your master task management system, but we can read from it and bring that information in. Okay. So that's a little bit about the back-end repository. As I say, it's not that exciting to look at, but it does facilitate a whole set of things that we can then do within EOS Studio. So in fact, just to maybe show some of that, what I'm going to do here is illustrate a few other things quite quickly. So I'm going to create a new data model, just to keep this nice and simple. And I'm going to connect to my demo environment, which is actually running SQL Server at the moment, but we do support a whole range of different databases. And when we reverse engineer, it will basically make a connection back to that database server, and it will then give us a list of the databases or data sources and allow us to select the one that we want to connect into. Come on. Click next, yeah. Okay, I'm wondering. I did have to update my VMware software actually earlier this week, and I think it has maybe made some changes to the IP addresses. So if this times out, I'll just quickly check the IP address it's connecting to, and I may just need to change that quickly. So in fact, when it's thinking about that, let me just jump over here and just check the IP address on this one. We told you it was a hands-on live demo, so we're seeing that. And that's an 88129. Okay, I'll just see what we're connecting to over here. Okay, I do apologize. I thought I'd checked this earlier. So that should be, as I say, in reality, you'll have your DNS names all set up and so on and resolve them. Because I've got kind of a self-contained demo environment with a few VMs running, I tend to have to use the IP addresses to make sure it connects to them. Okay, there we go. So I can then browse the list of the databases. I've got various ones available. I'm just going to take this one because I know it's not too big. And I'm just going to take the user tables. We can also bring in views, triggers, procedures. And this kind of available set of options will change a little bit depending on the database platform. I'm going to bring in everything. And yeah, and let's just go ahead and create a new data model. So there's a new data model. So it's got, by default, it's created both a logical and a physical data model, okay? And they'll basically match at the moment because it's read them from the database schema and created them. And I've got 11 entities in there. And of course, I can do things like apply different layouts to the diagrams. So all the things that you kind of expect, you can kind of relay out the diagrams, apply settings to them, apply colorizations, and so on. So within your studio, the main difference between the logical model and the physical model is that the physical model does represent things more technically in terms of the database structure. So it knows the database platform you're working with, and that's how we can also generate things like DDL change scripts and specify database platform specific storage parameters like partitioning information and so on. The logical model is a bit more abstract, so this doesn't have any of that technical detail behind it. It's really just got kind of details of the attributes, how they're defined, if we've got descriptions of them, and so on. Now, the other thing just to understand in your studio is that if I make a change to the logical model, that does not automatically synchronize to the physical model. And we think this is a really powerful feature because it may be you've got things that you want to represent purely at the logical layer, and you don't want those to go through at the physical layer, or the other way around. You might have some fields that are used purely from a physical perspective in terms of how you're managing maybe parts of the database schema, and you maybe don't necessarily want to represent those at the logical layer. What I'll do just to illustrate that is I'll go ahead and we'll just drop down a couple of new entities. So obviously these don't exist either at the physical layer or on my database schema at the moment. And we could go ahead and we could just add in a couple of attributes just to show that we're making some changes. My attributes always have very meaningful names in demos, as you can see. And we'll just save that away. And we could also add in a relationship, I guess. It doesn't really matter which one at this point in time. And I could go in and make changes to the existing ones as well, or create new relationships between them. But what you'll see here is if I do go now down to my physical model, this is just something that I do like to stress because it can be a little bit different to how people think it might work and how you manage changes progressing from logical, conceptual kind of layer down into the physical layer. Okay, so they are classified as separate models within my modeling project. And again, I could apply that layout to that so you can just see it a bit more clearly under the hierarchical layer. But those two new entities don't exist. Now, what I can do is I can run something that we call compare and merge. And this, as I said, is a very powerful little utility that takes you through step by step and allows you to compare things. And first thing I'm going to do is compare my logical model to my physical model. So that's the first option here. I can also compare it to other modeling projects or connect to my repository and compare it to a modeling project that's stored there. I can also compare it to a SQL file extract. And we might come back and do this one in just a moment, actually. I can compare it to a live data source and see the differences between the schema and the data model. But for now, we're just comparing logical to physical. So let's go ahead and do that. And again, for the demo, I'm just going to take all my defaults. So we'll include everything. And on the left-hand side is my logical model. On the right-hand side is my physical model. And it's basically just telling me that these new objects don't exist yet at the physical layer. So I could individually choose things. So if I wanted to bring in entity 2 and merge that into my physical layer, I could set that independently and ignore the rest. Or I can say, let's actually merge all my changes into my physical model. And we can generate a little report which will just document those differences from that comparison. So if we want to kind of store that away and audit as kind of like an audit trail, we can generate a report for that. Otherwise, we'll go ahead and say finish. What we'll now see is my physical model. we now have entity 1 and entity 2 created. And just to show you what I meant by it, it's a bit more aware of the database platform. If I do look at the physical model, and we'll see things like a storage parameters property, where I can kind of list things like my partition keys, if it's got compression, and this will all have an impact on the DDL code or the SQL code that it's generated. And we can also look directly at the DDL code that would be used to create this particular table as well that I'm looking at. Okay. So in terms of managing changes then back through, so obviously what I could then do is check these data models into my repository. It would then have a record of what changes I've been making. So I've added 2 new objects, entity 1, entity 2. Other people could then get access to it if they have the right security roles and the right permissions. They could start building other changes onto it. Maybe you've got different people working at the logical layer for a more logical conceptual view. Maybe you've got other people working more in terms of the physical layer and properties that are being set for the DDL code to be generated. So we could add that into the repository, and it would then be under the version control. The other thing that I mentioned as well that we can do is it can help us to control changes back into the database schema itself. And in order how we do that, one of the ways we can do that is I can run that compare and merge utility again. But this time I'm going to compare my physical model against a live data source. And typically this would obviously be in your test or your development environment as you're making these changes. And we can go ahead and say yes. Let's take the defaults. Let's include everything. So it's now just reconnecting back to that data source. And it's basically just checking, have any changes been made to the schema itself? So again, we can use this to make sure that the model and the database schema are in sync, in case a DBA has had to go in and make a change directly onto the database directly. But otherwise, we get that same kind of view where it's telling us, we've got this thing called entity 1. It doesn't exist over in the physical database. What do I want to do? So we could do the same kind of thing again. So we want to actually merge those in. Now, EOS Studio will not make changes directly to the database. Okay. Sorry, that warning box is just because I've done this a few times. So it's just telling me it's going to overwrite that temporary file. Instead, what it will do is it will do the comparison, but then it will basically bring up those changes in the form of a execution script that we can then take and run that against the database itself. So as I say, you typically then take the SQL code, you'd run it through your normal testing processes. DBAs could check it, make sure it's kind of what they're expecting, apply it to your test environment, make sure it's okay, and then from there apply those changes out into your production environments. So in terms of managing changes, it kind of works at a number of different levels, if you like, in that we're managing changes that we're making to the data model itself using the repository, but also managing changes in terms of generating SQL code to apply to the database schemas themselves as well. Okay, so we've gone through quite a few different areas there. So there's a few other pieces I just want to point out. And in fact, to do that, I'm just going to go and jump into another sample model that I have here. So I know I've got some things already prepared on this one, so it will save you watching my my slow typing. Creating again. I mentioned at the start that we have this concept of something called an enterprise data dictionary. So let's just take a little look at that. So on the tabs at the bottom here, you'll see we've got data model, which is what we're looking at here. We've also got this tab called data dictionary. So we'll bring that up. And the first thing that we see inside the data dictionary is we have this something that we call attachments. And again, we can have folders, a folder structure of these, so we can group them together to help us kind of understand what they're doing. And again, everything can have a description, a definition, and some notes associated with it. But the attachments are really quite cool. And again, these can really help you with managing changes as well in different ways. Because these are things that are not part of the database schema, but we might want to capture in terms of the database model itself. So if we're making a change, maybe we want to capture who's the actual designated owner of this part of the data model. Is this related to our kind of PII information? Are we tracking it that way? Has it got specific security implications associated with it, like a privacy level? So anything we add in here, let's bring one up actually, just have a look at it. I'll bring up privacy level because that's a fairly easy one to understand. So here I've defined an attachment. You can also think about it as a tag, if you like. because what we can do is apply this tag onto different objects in the data model or attach it to it. So I've given it a name. We've then got a description of what it's actually there for. I can then specify specific values. So I can specify, is this a drop-down list where it has to be one of these? Or is it more of a free format text file field? Is it a Boolean value of true or false? Is this PII related? Yes, no, that kind of thing. And what you'll see then is we can then do what we call binding. And in my case, I've bound or attached this definition of privacy level onto all my entity and table level objects. I can also do it at things like attribute level if I want to. That's really your choice as to what kind of level you're detailing, what you're adding in here. And you might just be able to see over here, if we look at the diagram and say, look at something like vendor, we've got our definitions of our fields, yeah, which are part of the schema, potentially. But we then also got underneath there, we're displaying these attachments, and it's telling us that this has got a privacy level associated with it, and it's internal use only. So we can really use this to build up additional context and additional documentation across our data models. And the nice thing is, because it's part of the data dictionary, I can define these definitions once and then reuse those same definitions across my different data models. So someone can be maintaining those, making sure you're capturing the information you want. And then what you can also do is using things like the web interface within the team server repository, you can actually search for these, or you can build a simple report of them and extract the information out. Give me a list of all of my tables where privacy level is set to internal use only. Give me a list of all my attributes where they're flagged as PII, that kind of thing. So it can help you really document and add a lot in there. And as I say, in terms of changes, you can also use it not just for things like security, but documenting, who is the actual owner, is it part of our governance process? So do we need to get specific approval? If so, who does that? All those sorts of things can be added into the data model as additional fields, as attachments, and they won't affect the actual schema or SQL script itself. So a lot of our customers do use this quite extensively. I won't go through everything else in the data dictionary today, but you can also add in things like reference values. You can have what we call a naming standards template. And also you can define what we call domains, which is a standard definition of a field. So if I want to have a specific definition for something like a postal code or a state code, I could define that in my data dictionary and again reuse that definition across my different data models. So again, that helps us with managing our change, because if I then need to update it, I can make it the update once in the data dictionary and apply that out across my different data models, then go and generate the new SQL code that's required to apply those changes into the database platform itself. Okay. I'm just going to pause for a second there, because I think Tim's been answering questions in the background, but I'll just, there's one question again, I think, just asking, will the recording be available? Yes, we are recording this, so we'll make sure to get that sent out to you once it's available on our go to webinar platform. And yeah, and I think Tim's answered the other question, which was about what variants of SQL does your studio support. Might be worth just quickly looking at that, because the other thing, I guess, that is kind of related to managing change, is what happens if you've got a database which is currently on, say, a SQL server, but you want to look at how you can maybe make a change and move part of that, all of it, across to a different database platform. So at the moment, I have my SQL Server physical model. So the code behind that is all SQL Server specific. Now, EOS Studio is not an automatic kind of conversion tool, so it won't do everything. But what it can do is some of the basics and simple things. So I could, for example, say, well, I've got my logical model defined. That's kind of documenting things at a high level. Sorry, this one's got quite a few objects in there. That's documenting things at a high level. It would be good if I want to then start making or thinking of a change to perhaps putting some of this into my new Snowflake platform or into my Azure platform, whatever it may be. So what I can do from the logical model, and again, actually, so I'm going to jump across here again, just keep it nice and simple so we haven't got too many objects. What I could do on this one that I reverse engineered, I could reverse engineer from SQL Server. That's what we've done here. And I could then say, well, actually, let's generate a new physical model. And I'm going to call this, we'll do it on Snowflake just as an example. And I can then choose the platform that I want to use the parser for. So there's a whole list of these, and it's the standard relational ones as you'd expect, but we have been doing more recently, better support for things like Snowflake. So I can scroll down here and say, let's make this a Snowflake physical model. And there's a whole list of these on our website, of course, where we document it all. But there's the Azure platforms as well, Azure's SQL DB. There's also some other ones up here related to kind of Amazon Redshift as well as a platform. So there's a whole set of these that we can choose from. And if I say create a new physical model, and yeah, I'll just do everything. I'll make sure I've got all my tables coming through. So the types of objects it can do are tables, views, users, and roles. Things that are specific to database platforms, procedures, functions, it can't convert those. As I said, it's not a conversion tool, but it can help you get those basic objects across. And again, let's just go ahead and finish that. So I now have a new physical model, which looks very similar, but this is now using Snowflake as a target platform. So if I look in the detail behind here, what we'll now see is that we actually have DDL code that's specific to Snowflake. And we can see that all in here with things that are different to how it looked for SQL Server. And we'll also see things like in the storage parameters, we get specific Snowflake storage parameters, how are these being stored? We can select those and that will kind of update the DDL. Likewise, clustering support, we can kind of select the columns that are available for those and so on and save those away. So in terms of managing changes as well, if we're actually looking to take some of our object definitions and manage the changes onto a different database platform, then EOS Studio can really help you with that in terms of the tables, the columns, and the underlying attributes all around that. Okay. So the other thing, I'm just looking at time, I think we're doing quite well actually. So I think we covered most of the main things in the data model itself that can help you with change. One thing's probably worth just showing you actually. Again, EOS Studio does support another type of data model. So this is not showing relationships. This is actually showing data movement. And again, this can help you in terms of managing change so you can understand where things are coming from, what are we doing with it, and then where's it being moved to or where's it being stored. So this really simple one is just showing that we've got some kind of staging data, which is related to addresses and states and provinces. That's being fed into a process. That could be part of an ETL tool, for example, or it could just be some business rules that we're applying to it. Within here, I can specify the input columns. So we're feeding in the city, the state, the province, and the state province ID. And I can then decide what the output column is going to be. So in this case, we're just outputting purely city. Within there, again, we can have a definition. What's it doing? Well, it's performing some kind of matching on the city name, and where it matches the state province code, then it's going to move it across to this table. That's perhaps part of our data warehouse or our data lake or whatever else it may be. And you can also add in the code that's actually going to do this for us as well if you want to. So this can be really helpful in terms of documenting that kind of movement rule and why data is being transformed or changed across your organization. And we can also, so first thing just to stress is we don't forward engineer, so we won't produce ETL code for you. This is really a documentation aid. But what we can do is we can connect to some specific technologies and ETL tools. So things like Microsoft SSIS, Oracle ODI, IBM DataStage, Talend, I think there's a couple of others as well. We can connect to those or read packages from those, and it will actually generate this kind of movement diagram for you as well. Okay, so it's generally called either data movement diagram or in your studio we tend to call it a data lineage diagram that's showing the lineage where some things came from, what we're doing to it, and where it ends up. And the final thing, just for completeness actually here, I won't go through this in any detail at all. Your Studio does have a scripting language built in, so you can also actually write scripts against your Studio to do all sorts of different things. Pretty much anything you can do in the tool, you can write a macro script to automate that. A lot of our customers do use it if they want to import information from specific flat files or export it. So I could, for example, say this data lineage diagram, let's export those columns out into an Excel spreadsheet format. So I'll just do all of them because there's not very many. So that'll call into our API and that little macro script behind it. It's telling us it's done it now. And if I jump across to Excel, tiny Excel, make that a bit bigger, we've now just got a custom export into an Excel spreadsheet, which is giving us the name of the data flow, the input columns, the description, the code itself, and then the output columns and so on. So again, if you need to share that or take that out into other systems, there's lots of ways that the macro can actually help you to do that. Okay, so I think what I'll do just for the last few minutes actually is I think it's also important to show you how we can publish some of this information in terms of a browser-based interface. So if I'm someone who maybe needs to understand some of this, but I'm not actually doing the modeling, let's go over here. Using just a web browser, I can connect to the repository. And again, as long as I've got the access roles and the rights to do this, I can then browse the different data models. So if I know what I'm looking for, I can use the Model Explorer and expand that out. So that's some of the models that we were looking at earlier. There's that one. Interesting. Okay. Oh, sorry, I don't know why it's on a real go slow today for some reason. So that was the data model that we were looking at. I'm just being impatient. And there's our logical data model that we're looking at. If we hover over it, we'll see little thumbnails pop up of the models we're looking at, or we can actually drill into the detail and see the data model itself. So I can't make changes to the objects. I can actually move them around, and I can take a screenshot, print it out, resize it, and it is also clickable. So if I do want to see more detail, technical information about how we've defined employee, I can double click on the actual image there, and it will then go off, and from the repository, it will pull back the information related to this entity definition. So we'll get the description, we'll get all the attributes, we'll get where it's used in terms of different submodels. So you can see this one's being used in 1, 2, 3, 4, 5 different models. And I could go and click back the other way and go and see the image of the models in there. And I hope on this one, yeah. I did mention something called universal mappings. So universal mapping allows us to create a link between objects that are defined in different data models. So if I reverse engineer from my HR system, and I reverse engineer from my I don't know, my product system, we might both those systems might have objects that are related to a person. What does a person do in terms of a product? What we're capturing about a person, that's part of HR. Now, there's obviously some kind of correlation there, but they're not directly related, and they might have different definitions. So universal mapping allows us to create a link across the data models, so we can then say, well, if you're looking at the definition of employee here, and you've been looking at this data model, I can now see that actually we've also got a definition of employee, which is stored in our corporate conceptual model. It's also stored in our HR database model, and it's also stored in some of these other objects as well. And I could then go across and look at the details behind these. So there's a detail of that model. There's the logical model. And again, we could then kind of drill into that, start looking at the information and working our way through there. And depending on what we want to do, if we wanted to see, okay, there's a person there, we could then go in and view the image of the model in the other data models that are available. So the first thing that the web interface provides is the ability for you to be able to browse, and also actually really powerful. If I'm not really quite sure what I'm looking for in terms of a data model, but I know I'm interested in definitions related to employee, as you saw there, I started typing employee and it started filtering off and showing me all the matches here. So I can see that there's an entity defined in this logical model. There's a table definition. I've got other things defined in other models. And I can also filter on the left there. So I want to see just my entities. I can filter off everything else. I can build up more advanced searches. And again, I can drill into these. Now, one thing that can be quite useful in terms of being aware of changes as well is even if I'm not the data modeler, so I'm not using your Studio Data Architect, I'm just looking at things from the browser, I can do what's called follow these objects. And what that means is if someone makes a change to employee, the entity inside Data Architect, and they then check in that change and update it and push it into the repository. If I'm following that object, I can receive a notification either by email or just by a stream coming into my browser interface to tell me that John has updated this on this date and time, and here's the differences. So again, just in terms of being aware of changes that are happening in the background, the web interface can be very useful for other people who maybe need to understand and follow those changes, but they're not doing those things themselves, and they're not directly using Data Architect in the repository. And finally, the other thing I'll just talk about briefly is the fact that we can also store business terms in the repository. These are not part of the data model, but they can be linked to the data model. So if I have a term called something like party, which is a very common one, I can see that's stored in my company-wide business glossary. I could click on that, and it's going to give me a little description. You'll see this is much simpler than kind of a technical description in the logical or physical data model. It's literally just saying this is what it means to the business. It's anyone who's directly involved or interested in contracts, transactions, etc., etc. I can customize these, by the way. I don't have to have these specific fields, so I can change those and have different ones, have extra ones, remove some. But what I can then start doing is say, well, actually, if I'm looking at party, is that related to other business terms? So I could look at the children of this business term. I'll see that there's then a breakdown. It could be an organization or it could be a person. It could be an adult, a child, or an employee. Well, that sounds interesting. Let's click on employee. And again, we can then drill down through that and we could see things like the attributes associated with it. So an employee could be made up of an employee number, employee type, first name. And we can also see if it's related to any others, which is similar to what we saw before. So it's actually related to an employee skills matrix, a business process, an employment contract. And then the other nice thing is because it's all stored in the EOS Studios repository, I could say, well, actually, how does employee as a business term, how is that being implemented in terms of our data models, then ultimately into our data sources? So from there, I can then drill down and I'll see all the different data models that I've linked it to. And again, we could then start expanding this out. So this is one of the ones that we were looking at earlier. So I've got one definition in there, it's stored in the logical model, and I've got an employee and a full-time employee. I think this one's got a few more in there. Yeah, so I've got logical definitions here, a few more things that are related to it. And again, from here, I could then double click on these, see the definition, see where it's used, and then open up, my actual data model that's associated with it. So I can browse either from the data model itself, if I know what I'm looking for, and kind of click up and up and up to get to the business terms, or I could start with a business term search and then kind of drill down into details of other business terms. How is that related to things at the logical layer? How is that related to things at the physical layer? And ultimately, we can actually have a data catalog which would describe the actual data source or database itself, and we could link through from the data model into there as well. So, we can see how all these things are related together, helping us document them and helping us understand as changes are being made into the logical and physical models. Okay, so I think we're getting pretty close to the time we'd allowed, so I'm just going to pause for a second. I think Tim's been doing a really good job of answering all the questions as they came in, actually, so I think we've got pretty much all of them covered, but we've got a few minutes, so if you think of anything else, do feel free to enter that into the chat. But what I'm just going to do really briefly here is if I just exit full screen mode and let me bring back up my my PowerPoint and follow those views around. So just as a quick recap, we covered quite a few things there, quite a high level. We like to do these live demos to give you the chance to ask questions about things as we go along. So hopefully you'll be able to do that and get answers. But just as a quick recap, we started off just explaining a bit about the repository, how that can manage the models itself in terms of we check out to make a change, we check it back in again, we can take snapshots and then releases. We then looked at how we can manage changes at the data model level between things like logical and physical and using compare and merge to synchronize those changes, and also how we can generate change scripts for the database itself as well. We then moved on to a few other topics that are kind of related and things that can help us with managing changes by centralizing things. So the enterprise data dictionaries, single place to define our definitions. We can add in those things that we call attachments to add more context into the data model. And then at the end, we had a very quick look at the universal mappings as to how we can link across different models and show potentially impact analysis of changes. If we're making an update to this model, we do need to be aware that there's a similar definition over here in this model. And again, we brought up the web browser interface just as a quick look at how that kind of allow you to collaborate with other business users and other people in the organization. So as I mentioned, lots of things out there on the web, so I'll just leave that up there, but you should be able to download this actually as a handout directly from GoToWebinar. And you will get sent a link to the video recording afterwards as well. It sometimes takes it a little bit of time to render that, so it might probably come through in the next day if it doesn't come through later on today. And if you do think of something, as I mentioned, fill in the contact form up on the website there, and someone will come back to you and follow up and make sure you get the information that you need. Okay, so I'm not seeing any more questions coming in, so I think we covered that. So I think all I'm going to say there is thank you all very much for attending. I hope you found some of that useful information. We do, I think, run a couple of these. I think usually they're about every two or 3 weeks, depending on topics that we're covering. And they tend to focus on different areas in the OR Studio. Our product manager did one just last week, actually, which was focused on some of the new features we've added into version 19.2. And that's all related to supporting hierarchical data stores. So things like MongoDB, having the ability to generate JSON code from there as well. So we're moving along from supporting, just the traditional relational databases now to allowing your studio to actually represent and model things that are more flat file based, as I say, such as a MongoDB structure or a JSON structure as well. And that recording should be up on the YouTube channel and our resource center on the website as well. So if perhaps you're looking at your studio for the first time and you're interested in that kind of structure, it's definitely worth having a look for that one. Or if perhaps you're using your studio, but you're maybe a version or two back, again, that'll give you a quick overview of some of the new things that have been added recently. Okay, I think we're pretty much at time. So as I said, I'll just say thanks everyone for attending. And as I say, please do get in touch if you think of anything after we end this webinar. Okay, thanks everyone.